In this lesson, we're going to be talking about evaluating functions. By the end, you should be able to determine the range when given the function and a determined domain. Evaluating functions. When we're evaluating functions, the main thing that we're looking for when evaluating functions is looking for the range when we're given the x values. What you're going to do is you're going to take your x values and you're going to substitute them into your function. And then whatever you put in, you'll get out your range, and then you'll have your y values. When you're evaluating from a graph, pay close attention to the way that it is written. If it says f of 6, so f of a number, that is different than saying g of x equals a number. If the number is inside of the parentheses, inside the function notation, that is representing the x. So that would be the x value, and you would be looking for the y. So in this case, when f is 6, you're looking for the y, and in this case, we can't identify that because it's not on here. But what we could identify is the 5. So when f is 5, or when x is 5, the y value is 3. But if it says g of x equals, or f of x equals, if the number is outside, then this represents our y. And so now we're looking at the y value. And the thing to note with the y values is a lot of times the y values can have multiple x's. So for this particular case, when y is 1, x is -1, x is 1, and x is 3. So we have three x values here that go with this one. The big thing to note here is that you will start to see things like f of x or g of x or h of x. Those representations all mean the same thing, but we use different letters when we're dealing with multiple graphs at the same time so that we can distinguish between the graphs. When you're evaluating from an equation, again, f of x is function notation. It means the same thing as y. Remember that f of a number, so f of 3, means that you're taking the 3 and you're substituting it in for x in your equation. But if you see f of x equals a number, so f of x equals 1, it means to substitute in that value for y instead. Okay, so here we have a graph and we want to evaluate our function from the graph. So this first one says f of 6. So we want to find the value when for f of 6. What this says is look at the y value when x is equal to 6. Remember, when it's on the inside, it's telling us that x is 6. So when x is 6, we go along the x-axis. We see that when x is 6, the y value that is there is 0. So again, it says, what is the value of f of 2? This means find y when x is 2. So again, we go along the x-axis, we find x is 2. We go up and we see that its y value is 5. So the value for f of 2 is 5. Okay, so it says, what is the value of 3 times f of 5 plus 1? So again, we're going to start with the innermost part here. So we're going to start with this f of 5. So when we're looking at f of 5, we go to the graph. Remember, this is saying what is y when x is 5. So we go over to 5. We see that when x is 5, the y value appears to be at 1. So we'll call it 1. So f of 5 is 1. And then what this says is take that value, so this 1 that we have, multiply it by 3, and then add it to 1, and that gives us a value of 4. Okay, here we have something a little bit different. This is saying f of x equals 4. So remember that when we're looking at f of x equaling 4, this is saying y equals 4. So if we know that y is 4, we want to know what the x value is. We're going to go and we're going to look at y being 4. Now here's the part that you need to be careful of. There are 3 values here. When y is 4, x is at 1.5. X is also at about 2.5. And x is also at 9. So there are 3 x values here, 1.5, 2.5, and 9. Now remember that it is okay to have multiple x's going to the same y, but you cannot have one x going to multiple numbers. says how many x values make f of x equals 1 true. So it wants to know how many x values make y equaling 1. So how many x values have a y coordinate of 1? So we come over here, we look, we see that there's 1, 2, and 3. So there are 3 values that make um, that particular part true. Now, it says for what values of x is f of x greater than or equal to 4? And we want to write this as an inequality. What we would look at is we would look at, again, f of x being greater than or equal to 4. So these are all of the values where y is greater than or equal to 4. So I'm going to look at all the parts above this yellow line right here. And that would be, or let me darken this a little bit, that would be everything above this line. And so we see at 2 points. We see here and we see here. So we see that x is greater than or equal to 4 between 1.5 and 2.75. So this is that first part. Remember, when we're writing our range as an inequality, that you list the first value first, the second value second. If we're including it, make sure you use the equal to signs in there, and the variable goes in the middle. And this would be x is. And then here we see when x is greater than 9, we see when x is greater than 9, then it is also greater than or equal to 4. And so in this particular case, we would not need to list 2 numbers because everything after 9 is also going to be greater. Okay, use the graph to evaluate the function. Okay, so when f of 3, remember what this is saying. This says go to x being 3 and figure out the y value. So the y value here is indeed 2. Again, f of negative 2, this says find where x is negative 2, then find its y value. That y value is 1. F of x equals negative 1. This says go down to negative 1 on the y and look at all of the x values. So we have negative 0.5, we have looks like negative 3, and then we also have 1. Remember that you're going to list these in order, so negative 3, negative 0.5, and 1. There are 3 x values there. You need to make sure that you list all 3 of them. Now remember that this is a function because this would indeed pass what we call that vertical line test. Okay, for each function we want to find the indicative value. So f of 4, what this is saying to do is take your function here, this negative 3x plus 10, and substitute in the 4 for x. When you do that, you'll get negative 3 times 4 plus 10. That's negative 12 plus 10, which is negative 2. Same thing for negative 9. We take our negative 9, we substitute it in for x, and we evaluate to get 37. Here we do the same thing. Now there are 2 x's here, so when I've substituted in the 6, I need to make sure that we put it in both places. So 6 squared and 5 times 6, and then you subtract and you get 65. And the same thing for the negative 4. Now I know that I put 4 here. I'm going to go ahead and add that negative sign in there because it does affect it. But the answer to this one is still going to be negative 5. Finding the value. Again, this first one is like we did on the previous page. You're substituting in the 2, evaluating. Here, you're doing 2 parts. You're going to substitute in the 1, and then into this, and then you're going to add the 4 on at the end. Here is the same as a number, so we don't have a 1 or we don't have a 2, but now we have an expression. In place of x, what you're going to put is this 2c plus 1. So what you have is 2 instead of 2x. Now you have 2 times 2c plus 1 plus 5. And then you'll evaluate, so distributive property here, and then add to the 5 at the end to get 4c plus 7. Okay, again, this part right here is not any different than what we've been working with. So you're substituting in the 4 into each of those places. Here, again, just like we talked about on the last one, we have an expression now instead of just a number, but it doesn't change anything. So instead of z, you're going to have 5a. So instead of z squared, you're going to have 5a squared. Instead of 3 times z, you're going to have 3 times 5a, and then you'll evaluate. Biggest thing here is make sure that you square the number and the variable. So 25 would be 5 squared and then a squared. And then distribute or multiply here. So 15a, and you'll have an expression. You won't have a singular number. Here, you work with your we work our way inside out. So we're going to start with the h of g part. Similar to h of z, instead of a z though, you're going to replace that with a g. And then you're going to take that whole function once you've done that and you're going to multiply it by 2. So you're going to do that distributive piece here to get that 2g squared plus 6g minus 8. Okay, before you move on to the next video, the thing that I would like for you to consider is the difference between writing f of 6 and f of x equals 6. As usual, please subscribe to our video, and I look forward to seeing, or subscribe to our channel, and I look forward to seeing you in the next video.